All right, this is for all the people taking track pictures and for Lily and whoever else is gone, whatever. I'm just going to go through the next. We decided we want to do maybe 3 pages just to get caught up and stuff. And this page I don't think takes very long. So we'll do this one, and then we'll do the one with the clock, and then we'll hopefully do the birthday one, okay? And we'll go through all of that information all at once.
Junior high track. Go to the gym for pictures.
There's junior high track. Okay, so we're going to go through and write out like this information just really quick. Mean is average. You know this already. Median is the middle. Mode is the most occurring number. Range is the biggest minus the smallest. And then mid-range. Do you know what mid-range is? When you do a box and whisker plot. Okay, you have your box and you have your whiskers and all that good stuff, right? Like this is your smallest number. This is your biggest number. This is your median. Okay, this is the quartile 1. Do you remember doing that? And this is the quartile 3. Your mid-range is going to be Q3 minus Q1. In other words, it is the length of the box that you have. I am videotaping right now. Yes. Yep. Q3 minus Q1. So it's the length of the box. Standard deviation, the rule of thumb for standard deviation is taking the range. I don't think you have to do this below. Range and divided by 4. That gives you a guesstimation for the standard deviation. Okay? I should have put box and whisker plot like over here under where it actually says box and whisker plot. But anyway. 5-number summary. The min is the min, the max is the max. I don't know that I can clarify that anymore. What? Yep, it's the range divided by 4. I don't think I make you do that. Oh, yes, I do. Yes, I do. I do make you find the standard deviation. Okay, but this is just like a guesstimation for the standard deviation. It's not the exact standard deviation, which is what I want you to do. Okay, min, max, median is finding the exact middle. Okay, if you have 17 numbers, who was asking me this yesterday? Jackson, maybe? No, Molly. Molly was asking me this yesterday. You have 17 numbers, right? 17 numbers all the way across. So these are my 17 numbers, blah, 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 17 numbers. Will you have an exact middle number if you have 17 numbers? Yes, your exact middle number is going to be this one right here, whatever that is, right? Whatever the middle one is, okay? Then when you go to find Q1, you cross this middle one off and you use this range to find the middle of that, okay? To find Q3, you do the middle of those guys. But since you have an exact middle number, you'll kick him out, and then you'll find the Q1 and Q3 based upon those numbers.
It smells in here.
Okay? It smells in here. You just walked in. How do you know it smells in here?
It's going to always. It always smells in here.
It always smells in here? Okay. I just can't help myself. Indy. You know.
I'm moving up here because
Okay, that's fine. Lily's gone today. Okay? Box and whisker plot. There we go. Okay? Find each of the following for the height data. So you might need to put your height data in order is what I would probably do first. Find the mean, median, mode, range, standard deviation, all that good stuff for your height data. And then you're doing the same thing. Don't look at resting temp, this is wrong, and running temp, this is wrong. That's from last year. This should be height, and this should be wingspan. Okay, so you have your height information from up above here, and then you're going to repeat the height information, but you're going to find the 5-number summary, min, max, median, that stuff. And you're going to do the same thing for wingspan, and then you're going to do a double box and whisker plot down here. Okay? So like your scale, I don't know, maybe needs to go from like 50 to 80 or something like that, right? What's in the middle of 50 and 80?
No, you need to replace the back paper.
70.
Have you done much?
60. Oh, wait a second. I can't math. We'll go 50, 55. And you're all coming in now.
Take the back page off.
Yep.
This one off.
Yep. 50, 75, 80. We'll go like that. There's your scale. If you want to do your scale on the back. No. So Kelsey right now is passing out a paper. There are a few typos on the last page of your packet. She fixed it, so rip that one off and put this one on. Okay? So this is not more. The very back page. This is just replacing the very back page.
Can I have a stapler?
There's one stapler that doesn't work, and I think Ashton has it. Yeah. So there's that. Okay.
Have you done much?
We just went through some of the stuff on the third page.
Leave that up there.
Okay, I'll leave it up there. Okay, if you're watching this video, I don't know who's watching because I think everybody's trickling in, but if anybody's watching this, you can skip ahead. Lily probably, maybe.
Range divided by 4 is.
Yes, that is the rule of thumb for standard deviation. That's how to find the standard deviation, like an estimate for the standard deviation, just a really easy, quick way.
Oh, okay, sorry.
Okay.
Why didn't you write the box with whisker flat right under it?
I don't know because I didn't see it. I was going through the stuff over here and I wrote my box and whisker plot and I was like, oh crap, I should have wrote it over there. Anyway, so it's the smallest number, biggest number, median, Q1, Q3. There they are. So this page will deal entirely with height and wingspan, but you may need to put them in order. Okay? So,
And Q1 is.
Q1 is your quartile 1. So over here, I kind of said this a little bit like before you guys all started walking in. So if you have your numbers in order and you have your minimum here and your maximum here and you're finding the median, okay? We have 17 kids in this class. Will you have an exact middle number if you have 17 kids?
Yes.
Yes, because it's an odd number, okay? So whoever is here in the middle is my person in the middle, that's my median. When I go to find Q1, which lives in here, you will cross this middle person out to find Q1. And you will cross that middle person out and only use this range to find Q3. Does that make sense? Yeah. Okay? So because you do have an exact middle, you'll kick them out to find Q1 and Q3. So be careful of that. Okay? Work together to put them in order if you want. That's kind of the pain in the butt. Okay, that's this page. Height and wingspan, those are the two things you're comparing, and you're doing a double box and whisker plot. I went ahead and labeled the scale. You can do it like that if you want to, because I think it mainly goes from 50 to 80. So 50, 55, 60, 65, 70, 75, 80. And then you'll have your 2 box and whisker plots up above here. So however this looks, don't copy this down, but you'll have something like this. This is what it will look like at the end. Oop, not that way. That at some point is what your box and whisker plots will look like. Make sense?
Yep.
Good? Okay? All right, let me erase this. You'll just put those right above there. Okay, and that's all for the third page. I say that's all, but like that's a lot. Right? That's a lot. Now the next page is a little bit easier. It's a lot faster anyway, right? Okay, this box down here has to go with the third page. Are we ready for the third page?
No.
No? No, not yet. Okay, I'll wait for a second.
On number 10, why does it say resting temp and running temp?
Cross those off and put height and wingspan. Good question. Yep, if you did not cross those off, the resting temp, running temp, you're going to compare height and wingspan and not resting temp, running temp. That was another typo that did not get fixed from last year because we used different data last year. We did temperatures and such because like we had access to thermometers like crazy last year, right? They had like, they were taking temperature all the time. So, anyway. Okay? You tell me when you're ready. I know I'm going really fast, but I'm trying to just get through all the information and then just give you time to work. Okay? Okay. Empirical rule, you guys have a laminated sheet of this that's bigger. If you want to use that, you can. And then z-score. To find a z-score, what does a z-score stand for? Again, do you remember? Like if I say your z-score is 2.5. What's that mean? 2.5. That's the number of standard deviations you are above or below mean. The mean. If you're below the mean, you're negative. If you're above the mean, you're positive. Okay? So this is the formula for calculating standard deviation. You got 3 variables. S is standard deviation. X bar is average or mean. What's X? What is X? Let me know. The number of standard deviations you are above or below the mean. So X is your number, like your height or your wingspan or your pulse rate or whatever it is we're talking about. That's your number that we're trying to find for z-score. Okay? Good? I don't know where you're at. Are you ready for me to move on?
On the line above that, scale or whatever, is that the one where it has to make
Yes. Yes. So that's just your scale. So
one for each?
make one for each. So the one will be here and one will be above it. Yes. Yes. Okay. All right. You ready for the next page? That's really all the information that you will need. The average pulse rate for your class is, I gave it to you on the sheet. What's the average pulse rate for your class? Somebody see the
69.29.
69.29. And the standard deviation is
9.21.
9.21. Fill in the following bell curve. I don't have a bell curve. Fill in the bell curve and use the information to answer the following questions. Should we do this part together?
Yeah.
Sure. Okay, what goes in the middle? No. Well, 0 is a z-score, right? But 69.29 goes there. And then we go 1, 2, 3, and 1, 2, 3. I guess we could label them here if you want to. Whatever, it's fine. Now what? How do I find the other markings? This one, this one, this one.
You add and subtract this.
You add and subtract the 9.21. Somebody have that in your calculator already? 69.29 plus 9.21. 78.5 plus 9.21 is 87.71 plus 9.21 is 96.92. Subtracting 69.29 minus 60.08, 50.87, 41.66. Okay, I'll zoom in on that. There's your bell curve. This is +1, +2, +3, -1, -2, -3. And then you either use the empirical rule with the percentages or z-score to, like the formula for z-score to answer the questions. And that's all.
Where's that?
Zoom in. Right, like the top of the, or the bottom of the last page that we just did. Yeah? Yeah. Okay. You still can't see? You can't see those numbers? You want me to read them to you? Okay. I know, yellow, I don't know if I should have used yellow.
So A is
You're at a
just,
bad angle too.
A is just 60.08 to 78.5.
Yeah. Mm-hmm. Yep, very nice. This is asking for 68%. Oh, within one standard deviation. Yeah, exactly. Mm-hmm. Right. Okay, good. I know I'm going like through all of this at one shot, but then I just want to just give you time to work. Okay? Confusion? Okay. And you can always ask me later. Let's go down to this box right here. Converting data to a percentile. The percentile tells how many values are less than me divided by the total number of values. So if I am like the 6th person in the class, like my data value is number 6, I would take 5 and divide by 17 and take it times 100, and that would tell me what percentile I am, right? If my value is 6th in the class. Now, you will have to put these in order. So let's say 5 divided by 17 times 100, I would be in like the 29th percentile. Does that make sense? The number of data values less than you, so put them in order. How many people are less than you? And then divided by 17 times 100. You are in the 29th percentile. Now, this part, if I'm asking about your values, like my pulse rate was blank. Unless somebody else has the same pulse rate as you, these should be different, right? So like you can work together, but you can't work together. Does that make sense? Like, you know, whatever. I am in the blank percentile. Nobody should have the same percentile unless they have exactly the same pulse rate. I'm not sure if that happened. But anyway, okay? All right, the other way around for like number 13 for this one, this one, this one, this one. Okay, here you go. Converting percentiles to a data value, you take the percentile. So let's do like 13A together. We are wanting the 25th percentile. There you go, 25th percentile. I take the percentile, 25 divided by 100, which you can probably do it in your head, is 0.25 times, what is N? 17. What's 0.25 times 17? What? 4.25. Okay. If it's a decimal number, you round up to the next person, right? You round up to the next person. So this would be 5. So you would take the 5th person for pulse rate. The 5th, like if you're putting them in order from least to greatest, right? Should we go and find the 5th person for pulse rate?
Sure.
Okay. All right. Do you see how we get 5? 4.25, we round up to 5. I'm pretty sure all of these come out to be decimal numbers, so you don't even have to worry about whole numbers, right? 40 percentile, 55 percentile, 90 percentile. So we're looking for the 5th person, okay? So I'm going to go to my data and make you really dizzy. We're doing pulse rates. Okay, so who's number 1 for pulse rate? Thinking that we're going least to greatest. Who's number 1? Ellie. Ellie's number 1. She has a 53. Who's number 2? I see Abigail with a 57, so 2. Then we've got MJ with a 61, so you're 3. 4s, I see a 62. Anybody lower than a 62?
Nope.
TJ is number 4, and we're looking for number 5. And the winner is Josh. Josh is number 5. So Josh with a 63 would be in the 25th percentile for pulse rate. Does that make sense? That's how you're finding these? Are we super snowed and confused?
No.
So you'll put Josh. Find the data value for pulse rate that convert to the following percentiles. So you can either say 63 or you can say Josh. Okay, or both. That's what I did. Okay, happy with that? Is that enough, or do you want to continue on for probability?
That's enough.
That's enough? That's enough. If you get done and want to start probability, these are not hard. Like number 15, find the probability that that your class has a birthday that's not in December. How many of you have birthdays that are not in December?
Everybody.
The probability of selecting a person not in December? 100%, right? Because nobody has birthdays in December, right? So some of these are not hard. When you get toward the bottom, they do get a little bit more difficult, and we can deal with those tomorrow. But if you want to work ahead and you get done, go for it, okay? All right? I'm just going to give you time to work, and you can ask questions. I know I've given you a lot. It feels like a lot. Okay. All right. I'm going to stop recording because I think, yeah.